Hey everyone, Mr. Miller here with another lesson for you. Today we're going to be looking at systems of equations. So the other day you should have learned how to solve by graphing. If you have two systems of linear equations, two lines, they come together and that's the solution. Now graphing is useful and you can always graph. The only thing is there's a couple of things with graphing. First, it has to be in slope-intercept form. It has to be y equals mx plus b. Some of the lines you'll see today aren't always in that form. The other thing is sometimes those lines can come together at a point that's maybe not too pretty, maybe like 2.5 comma 0.5. And sometimes it's hard to see that on a graph. So we're going to learn a couple other ways today to solve. The first way we're going to take a look at is solve using substitution here. Substitution. So there's 4 steps. Go ahead and pause this video and write these down. I'll go through these steps as we take a look at an example, but just go ahead and write down these steps. So the first one, we're going to solve for a variable. That means we want either y equals something where the y is isolated or x equals something where the x is isolated. So it's just 1y or 1x equals everything else. Right? Step 2, we're going to substitute into the other equation. Step 3, we're going to solve that new equation. Step 4, we're going to plug back in to find the other variable. All right, here's our first example we're going to take a look at. So we have a system of linear equations. It's a system because we have more than one. Linear because we just have x and y. So these are straight lines. All right. First thing we want to remember is when you see two equations here, anytime you have an equation, like let's just say I had one equation, this top equation, 3x plus 5y equals 13. We can't solve that because there's two variables. We have an x and a y. The only way you can solve an equation with two variables is if you have two equations to work with. So that's why we need a system to solve these. All right. At this point, we're going to go through those steps. The first step, I need to solve for a variable, for y or for x. So you can kind of see there's one variable here that stands out to me that I want to solve for. I want to solve for this y right here. I want to do that because it's one y. It's just a y. All right. All these other variables have a coefficient in front of it. So the second equation here, I'm going to solve for y. To do that, I need to isolate it. I need to move everything else to the other side. So this is 2x over here. I'm going to subtract 2x from both sides. And if I do that, I get y equals 4 minus 2x. Okay. There's my isolation. All right. So the next step here, substitute into the second equation. Now, this is where we get the name substitution from. This is kind of the tricky part here. We have y, and we have an equal sign, and we have 4 minus 2x. What this means is that they're equivalent. They're equal. Y is the same thing as 4 minus 2x. All right? Those are equal statements. Y equals 4 minus 2x. Now, I'm emphasizing this because on this top equation here, where we have, I'm going to bring it over here, 3x plus 5y. Here's the thing. Instead of this y right here, well, guess what? 4 minus 2x is the same exact thing, right? Those are equal. So here's what I'm going to do. Instead of writing y, I'm going to write 4 minus 2x, all right? I'm going to substitute that in right there. Equals 13. Okay, there's where the substitution comes into play. Now, you might wonder why I did that. Other than it's just called substitution, take a look at how many variables I have in this equation here. I just have x. If you have one equation and one variable, we can solve for this. So that's my next step. Step 3, solve that equation. The only tricky part with this is it is 5 times 4 minus 2x. We need to make sure we distribute that. So I have 3x plus 5 times 4 is 20. 5 times negative 2x is minus 10x equals 13. Next step here, combine like terms. I have a 3x minus 10x is negative 7x plus 20 equals 13. We want to solve for x, so I'm going to move this 20 to the other side by doing the opposite. I get negative 7x equals negative 7. Last step here, divide both sides by -7. We're trying to solve for that x, so I need to isolate it. I get x equals 1. X equals 1. Okay. Now, step 4 here, you'll see plug back in to solve for the other variable. Okay. If we have an equation with two variables, we can't solve it, but here's the thing. We just found out what x equals. We found out that x equals 1, so now we can go back up to either one of these equations. Pick one, choose one, whatever you want. Equation 1 or equation 2. If we know x equals 1, now we can solve for y. So I'm going to bring this up here, and I'm going to bring it in to that first equation, or the second equation, okay? We're basically substituting again, all right? 2x, but instead of x, I'm going to write 1 because x equals 1. Plus y equals 4. 2 times 1 is 2, plus y equals 4. And if 2 plus y equals 4, that means that y equals 2. All right, so I have x equals 1, y equals 2. I'm going to write this answer as an ordered pair where x is 1, y is 2. That's my answer there. All right, now we always want to make sure we double check this answer because this has to work for both equations, right? These are the only variables that work for both equations to satisfy both equations. So make sure you check your work. I am out of space, so I'll let you do that. And then we'll take a look at one more problem here together. All right, we have another system of equations that we're going to solve by substitution. All right, you should already see which variable kind of stands out for you. And if you just do that, and you kind of see we have a y here. It's just one y, so that's the one I'm going to solve for. I'm going to solve that first equation for y. So I'm just going to add 2x to both sides. So I get y equals 6 plus 2x for that first equation. Second step, I'm going to plug that back in. I'm going to substitute it into that second equation. So the second equation here, 4x minus 2y. But hey, y is the same thing as 6 plus 2x. So instead of writing y, I'm going to write 6 plus 2x equals to 5. All right. We need to just solve for x. We have one variable, so we can solve an equation for one variable. We have 4x minus 12, minus. Make sure you distribute that. So negative 2 times 6, negative 12. Negative 2 times 2x is minus 4x equals 5. So we get 4x minus 4x is just 0x. And we get equals to 17. 0x equals 17. Now, 0x equals 17, that doesn't make sense, right? Right? 0x equals 17, that doesn't make sense. This is one of those cases where we don't have a solution. And let's take a look. All right, so we got to 0x equals 17. This doesn't make sense. This is going to be one of those cases where there's no solution. And it's probably easier to see before the step, if you just do 4x minus 4x is just 0. You get to, before I move that negative 12 over, you get negative 12 equals 5. Does negative 12 equal to 5? No, it doesn't. So we have no solution. Whenever you get to something that doesn't make sense like that, it means there's no solution. Now, I'm going to show you graphically because it's a little easier to visualize what this looks like when there's no solution. Okay. Remember to graph, we need it in slope-intercept form. So real quick, you need to solve for y. I would have this first equation would be y equals 2x plus 6. The second equation would be y equals 2x minus 5 halves or minus 2.5. All right, quick, if we graph these, just a quick sketch here, you'll see that this first line has a slope of 2 and a y-intercept of 6. So kind of up there and goes like this. You'll see that the second line has a slope of 2 and a y-intercept of negative 2.5. So down here, same slope. And if you remember, lines with the same slope never touch, all right? So our solution, we're looking for a spot that these two lines touch, but they're never going to touch. They're parallel, and that's why we have no solution, all right? Next, we'll look at elimination, but I'm going to let you guys try a problem right now.